Okay, let us try these examples. Okay, in these examples we have a car moving straight lines for short times in velocity is the velocity equations given by 0.9 t squared plus 0.6 t, and we have to find out, or we have to determine the positions and accelerations when t equals to 3 and t equals to 0, s equals to 0. Then of course to find out this, okay, we have the velocity equations, which is v equals to 0.9 t squared plus 0.6 t. And of course this is not the accelerations not constant, then we have to integrate these equations to get the positions. Okay, then we know that actually the v is equals to ds over dt. Then to get the s, we have to manipulate these equations, then it's become ds equals to v dt. Okay, then of course based on what we have in the previous slide, to get the positions we have to integrate these equations. Okay, then it's become s minus s naught equals to, then if we integrate these equations, okay, it should be 0.9 t cubics power of 3 divided by 3 plus 0.6 t squared divided by 2. Okay, where we have s naught here, this is t, this is t naught, t equals to 0 until t equals to 3. Okay, then if we plug in the value, you should get 0.9. This part, if we put 0, then of course we have 0, then put 3 here, equals to 3 of 3 divided by 3 plus 0.3. This is multiplied by 3 squared. Okay, then if we solve it, you will get the distance travels when t equals to 3. Okay, and that's how we can solve for the positions if we have a velocity is in functions of time. Okay, if not, okay, then we can directly use the solve equations for v, a, and also s. Okay, this is a special case where the rocket feels the constant accelerations of gravity is equals to 9.81. Okay, in this case we can use the equations that we solve when the acceleration is constant. Okay, in this case the rocket travels upward. Okay, this is the velocity. Oh, sorry. This is the velocity when the rocket travels, and at the moment also it's reached and at the positions of 40 meters from the ground, and then at these times the engine fails, and then we have to find out the maximum height SB. Okay, this is 40. This is defined here, and then at that moment the velocity is 75 meter over second, and then the engine fails, then it still moving upwards until the velocity is 0. Then at this point it reaches its maximum height. Okay, this is maximum, so defined by SB here. Okay, then we have to find out other quantities, which is speed just before it hit the ground, which is V. For example, we put here VC. Okay, for example, we define as VC, which is just before it hit the ground. Okay, then of course, because this is the systems experience the constant accelerations, then we can have, or we can use the three equations to solve this problem, which is for example, then we can use that formula. Now it's become VB, which is the last position that we have the velocity when it's reached at maximum height equals to the initial velocity VA squared plus 2AC equals to SB minus SA. Okay, and this moment at this part, then of course this VB here 0, then VA equals to 75 squared plus 2, of course AC. Okay, now the robots move upwards, then the acceleration is pointing downwards, then of course we should add the minus sign here, because the directions of the acceleration is different, the directions of our S. Then we have here 9.81. Now SA is, sorry, this is SB. SB is the position that we want, still an unknown. Okay, minus 40. This is the position of SA. Okay, then if we solve it, then we should get about 327 meter. 75 squared to SB. Okay, that's the maximum height before, the maximum height it can reach after the engine fails when it's reached as equals to 40 meter. Okay, then secondly we have to find out the velocity just before it reach or hit the ground. Then we can use this similar formula, which is now the last velocity is VC squared, initial velocity for this movement from maximum height to the grounds, which is VB squared plus 2AC minus 9.81. Okay, because the directions always inverse of the directions of our S, then the last position is 0. The initial position is what is it? 327. Okay. Then VC, the interested, then this is 0. equals to 2 multiplied by minus 9.1 multiplied by minus 327. Okay, then so for VC, of course, we should have a VC is the square root of 6415175. Okay, and then if we try to solve it, we should get either plus minus 80.1 ms. Okay, and of course we consider the negative value here. Of course we consider the negative value here because just to show that the positive direction is pointing upwards and the negative is pointing downwards.